Testing, testing. Can you hear me? Hello. How you doing? Hello, Matt. How you doing, you horrible lot? I said, how you doing? Well, that's it. There we go. Hello there. Thank you. Thank you. Uh, clearly, a night or two of wild partying hasn't put you off waking up at some point in the morning, and you're still all here. Well done, you guys. So, I am going to talk a little bit about one of the things I did once when I got bored. My wife is strangely of the opinion that I never get bored. In fact, the opposite is true. I get bored very, very easily. I'm just very good at finding ways to fill my time up. And a couple of years ago, it was the pandemic, and that was a bit rough. Well, I say that, but probably like most of the folks in this room, I am strongly introverted. Consequently, my social life did not change demonstrably throughout the whole of the pandemic. In fact, if anything, I rather liked not having to go to the office and working in my pajamas. It was, actually, I'm still doing that. Don't tell anyone. So, I taught myself a couple of things. I've picked up the piano. I've been teaching myself to draw. I did that one. It's okay. It's okay. But I'm a bit better than that now. But yeah, the idea. I like to fill my time up. And so I also thought I'll do something computery, and I enjoyed it enough that I turned it into a series of blog articles and then finally into this talk. Hopefully you guys will have as much fun as I did. If you didn't, oh well, I had my fun. So my contact details, in the event anyone actually wants to speak to me again, they're all down the bottom there. I can bring it back up later. There's a link there to my, can we call it Twitter? I'm not sure anymore. The less than benevolent overlord will probably change its name again next week, and I don't know. But for the time being, I'm on all the social things, and you can find me if you need me. So let's move on. First off, this is going to be talking about functional programming. So briefly, excuse me, briefly, what is functional programming? I'll just whip through this so that you get an idea of what I'm trying to do. So it is a paradigm, not a framework, by which I mean it is a style of programming. You do not need to install a NuGet package to do functional. You can, you don't need to. C# supports pretty much all of the functional stuff pretty adequately. If you want a metaphor, think of a guitar, and you may use a guitar to play many styles of music. You could play rock or pop, or if you've got no taste, country and western. No, you get the idea. So it is with object-oriented or functional. There are others, but those are the big two. That is declarative, not imperative. Okay, some terms here. There are not only paradigms within programming, there are also families of paradigm. Imperative is the family to which object-oriented belongs. An imperative style of code involves being very concerned with the order of operations, with sort of having an invisible pointer that goes go here, go here, go here, do a loop, go here, go here, do a loop. Being precise about exactly how you start an object up and build it piece by piece, that is an imperative approach. Declarative is different. Declarative works more by defining what you want and then letting the environment get on with it. The most common form of declarative programming that most of you are likely to have encountered is TSQL. SQL is declarative programming because if you think about an SQL statement, you do not, well, you don't do anything. The computer does not execute those lines in the order you write them. Typically, but not exclusively, the select is the last thing executed, and yet the first thing are written. Do you care? No, why should you? So that is how it is more with declarative and, by extension, functional programming. The properties of functional programming. We have immutability, which means once a variable is set, it may never be changed, nor any of its properties. Everything is const, everything is read-only. You create it once, done. The only thing you can do is use it or not. Again, if you want a metaphor, think about maths working in a maths paper. You write out, if you're doing a full working, you start with the problem, and then you do this line based on the previous line, then this line based on the previous line, and so on. You can't retrospectively decide that actually that's not the value any longer, if you made a mistake. But other than that, that's how it is with this. Everything is read-only. It uses higher order functions. Now that's a funky name for something that's not terribly complicated. Higher order functions is simply functions which are passed into something as a parameter or out of something as a, hey Ponema, as a return type. So if you've used func or action delegates in C#, there you go. That's basically it. And in fact, link is a fantastic example of exactly how this is all done. Link, little secret there, is totally functional programming. So if you like link, you're in. Okay, expressions rather than statements. So a statement is something which does not evaluate into something, an object or a primitive or whatever. An expression always does. So a simple func delegate can be an expression because it evaluates to whatever your return type is. An if statement is, well, it's a statement. There you go, clues in the name. If, while, for, those are all statements. They do not evaluate to anything. They change the flow of the program. Functional programming does not use them. There are no ifs, whiles, fors, or anything like that in pure functional code. So in part of my project here, I am not using, or at least any of those, or at least to using them as little as I possibly can. There are some exceptions, and I'll get to that. Referential transparency, also known as pure functions, which means that a function, given the same parameters, same parameter values, that is, will always return the same result back, no matter what. No matter what state the system is in or anything, same values in equals same value out, and no side effects. Nothing else will change anywhere else. The old OOP technique of pass an object in, and then that object will be modified within the function and then passed back, and we don't know what's happened to it. No, we don't do that. Recursion. Everyone good with recursion? Good. So it's going to be a tough talk otherwise. Pattern matching. I used to have to explain this, but thanks to the gentleman sitting around the back somewhere, we do. There, yeah, I see you. That's Matt Torgerson. We do have pattern matching now in C#, and it's really flipping good. It doesn't do 100% of everything that pure functional pattern matching can do, but it is. We're talking 95% or better. So if you've used switch expressions, that's it, and it's really cool. And it's stateless. There is no, well, that's not entirely true. I have been told off for saying it's stateless. It's not. OOP is based on the idea that you have a state object which sits in the middle of everything, and you'll periodically poke updates into your state object. That's not how this works. State is a transitive thing. It's an emergent property. State exists for a moment, and then it is replaced with an updated version that's actually a different object. If anybody has used React Redux, that's exactly how you would do it in a functional language. You would have your state object, and then when you want to update it, you have a function which takes the old state object, a command, and maybe some extra parameters, and then it creates an entire new state object. So state exists for fractions of seconds, but it exists as a concept within the system, just not as a physical thing for long, depending on what you're doing. So why? I've ranted an awful lot about what it is, but why the hell? Why? Okay, reduce code noise. A lot of people skip this one, but this for me is actually one of my favorite features of functional programming. Functional programming is far more concise than the OOP alternatives. You use far fewer lines of code. Now, that's not just because I'm lazy, which I am, but it's also because reduced code noise means that it is easier to read the code and understand in a moment what it does, rather than having to hunt up and down, try to understand what this loop is doing and why. But also because you've made your code more concise and because you've done away with some of these statement structures, it tends to mean it's much easier to maintain because the code is more arranged in a more logical manner. When you look at functional programming, it tends to read like the way that you would describe this to your non-technical boss. You know, I do this, then I do this, then I do this. That's exactly how you'd write it. Whereas in OOP, those 3 steps, that whatever they are, they'll probably be scattered in about 5 different places, depending. It's more testable. Now, I know for a lot of other people, that's the big one, and fine. It supports unit testing. We have the whole concept of pure functions, and because we use pure functions, it's predictable. And because it's predictable, that means it's very, very easy to write automated testing. The system doesn't require a lot of setup. You just pass in everything the function needs and then get back a result. Strictly speaking, if we were going to go in purely functional, then you'd probably write everything as static classes and static functions that don't reference anything outside themselves. We can't really do that in C#, but that's the sort of end goal if we could. Okay, it's more robust. There are functional languages that claim that once you've actually got the thing to compile, then nothing can kill it and bring it down. That is probably entirely true. I do not doubt it. Now, that's not quite what we can do in C#, but we can get pretty close. So the closer we get to that pure functional style, the more robust your code is going to get. If anyone's ever used RabbitMQ, that is written in, I think it's Erlang. Yeah, I got some nodding. Erlang, which is a pure functional language. So it's easy in use in the real world. It's more predictable, which, I mean, we don't have, for example, the concept of throwing exceptions. That is not a thing. We don't worry about breaking the order of execution. We start here, we go down to here. We will do that every time, no exceptions. There's no branching groups of logic and stuff like that. It is much easier to get on with. At least I think so. Better support for concurrency too. It's stateless, as I've said. So if you're interested in things like serverless functions and all that, this enables that rather nicely. Or if you want to have concurrent processing of a queue or whatever. Because we don't have a state as such, we tend to get fewer problems with resource contention. And I'm not saying you couldn't have a race condition. It's probably still possible, but you're going to have to work a lot harder to get that to happen. So, right. Also, C# is not a pure functional language. It's a hybrid. That is a stated intention of the Microsoft team. He's over there, so I can get, yeah, we got, yeah, there we go. And it will never be purely functional, though. That is not a thing that is going to happen. Even F# is not purely functional, and probably never will be for various reasons. But the metaphor I like is that of a shadow. So I've been learning drawing, so I've been learning about the different components of a shadow. There's actually 12 or so, but for the purposes of this demonstration, there are two. There is the umbra and penumbra. Okay, umbra, if you look at any shadow, is the big, dark, solid bit in the middle. Penumbra is the grey, fuzzy bit around the edge. So when I write functional C#, I try and maximize the functional bit, the umbra, the dark bit in the middle. Make that as large and much of the system as I can and as purely functional as I can. But then there are always going to be places where I have to compromise, and I keep those around the edge of the system. I keep them small and tucked away where hopefully no one needs to see them, but there will have to be compromises here and there. And I'll talk a little about that when they come up. But I think there is actually a term for it these days. It's something like functional core imperative shell or something like that. But I like my shadow version, so that's what I'm going with. So on to Oregon Trail, which is the project I set myself. What is Oregon? I have to admit, I don't know if there's anyone here from the US today. I had never heard of Oregon. So I went and looked it up. There it is up there for anyone who, like myself, was curious to know what on earth it is. It's there. There we go. It's one of the states of the of America. So great. What's it known for? Well, I found some rather lovely pictures of the scenery, and my goodness, that does look fantastic. I don't know whether there's ever going to be an NDC Oregon, but, you know, I would go. I'd like to see some of this stuff. That looks really nice, that does. Cool. Nike. They are based in Oregon, apparently. Well, they have to be somewhere, and that's where they are. Named after the Greek goddess of victory, I believe, if in case anyone was curious. But, yeah, Oregon. And the 1980s film classic, The Goonies. Which is named after a part of the city that they're in called the Goondocks. It's in case anyone like me ever wondered about the strange title. And yes, set in Oregon, apparently. I forget which city, but there we go. That's a little potted history of Oregon for you guys. You're welcome. Also, the legend of the Oregon Trail. I found this painting of it. There we go. So I'm not going to turn this into a history lesson, but as I understand it, there was a push at some point in America's history when they were still settling to bring people from the East Coast over to the West, and they did indeed go over these long, long trails with these covered wagons pulled by oxen and encountered many and different things along the way. I believe the routes were not planned deliberately. It was something like a network of smaller routes that were made for fur trappers and the like, which gradually linked up until you had this one long continuous route across the US. There's the route they were taking. They're going all the way over here from Missouri all the way over to there, to Oregon. It's quite a long way. I believe it's thousands of miles, because America, when I looked it up, turned out to be really, really big. I had no idea, but yeah, it's really big. And there. So here's a few of the things they encounter on the way. You can kind of just about see it. This is just about the only picture I could find of it, but there is a mountain pass that they have to go through because there's a mountain range in the way, which was inconvenient, but they found a pass which allows you to get through relatively safely, and I think this is the best picture I've found, which isn't great. Also, you might notice these persons here shooting the local wildlife for food. This is a feature of the game, and in fact, not only that, but the game is text-based, and they still managed to include a shooting minigame in text. I will let you ponder that idea. I will show you later, but they did it. It's quite impressive. Right. Along the way, also, we encounter forts. These people who I'm sure are entirely happy to welcome their new colonial overlords, who are also encountered here and there. So, moving on a little bit. This gentleman is John Kemeny. He was a Hungarian mathematician. This is going to the 1950s and onwards now. So I don't know if anyone's ever heard it said that Albert Einstein was not very good at calculus. This is the guy that said it. He apparently was a mathematics genius. I'm not a mathematician, I will take the word. He worked with people like Feynman and stuff like that, doing maths calculations for them, so a really big deal. And he became the head of mathematics for a university in America, the University of Dartmouth, and he had a couple of interesting obsessions, at least for my purposes. And one of them, at least, was computers. Now, we're in the 50s and 60s, so computers is pretty new-ish. And he had the idea that computers were the way forward and that everyone should have access to a computer. Crazy stuff. It'll never catch on. So he teamed up with this guy, this is Thomas Kutz, and they implemented a couple of rather radical things in the university. One was a timeshare system. So computers in those days were colossal. They were massive. They were like the size of basements. And you would interact with them by putting together a punch card and then going along with your punch card, handing it to the person that administered the computer, going away, and then coming back in a few days when that person has gathered all the punch cards into a great big batch, hence batch processing, that's where it comes from, and fed them into the computer and got the results back. So this whole several-day process or whatever would then come back and say 404 exception or whatever. And then we'll have to go and have another go. So a timeshare system was a way to make the computer more imminently accessible. So what you did is had a series of terminals dotted around the university campus, and the computer would share its time between each of the computers. So every person could feel that they were connected to the computer and entering commands in something like real time. I don't know how quite quickly they actually operated. I've never seen one in real life. But in something close to real time, it would respond to you when it got around to you. So that meant everybody could have a go. And the other was that they wanted to put together a programming language. And that became bizarrely revolutionary. They called it the Beginner's All-Purpose Symbolic Instruction Code, or BASIC. These are the guys that put that together. BASIC was a revolution compared to many of the programming languages that were available in the day, which were things like COBOL and Fortran. I've tried looking into Fortran once, and I will not do it again. I'm sure it's very good, and apparently it's a great recipe for retiring early and possibly criminally insane, but fine. They wanted a programming language that was human readable and human usable. So amongst the concept was that every sentence, every line should have a verb in it and start with a verb which declared what the thing actually did. So there we go. That's some BASIC. Does anyone think this is a very good idea, by the way? I mean, it's true what I say, but right. So the other thing was it had line numbers. Now, I do appreciate very much what they did with BASIC. This is brilliant. The line number thing was not a good idea, which is why literally no one else has ever done it. So the idea was that you gave a number to each line, which basically became an ID reference for the line, and then you could go to that line. You basically got basic is interpreted rather compiled. It's basically a scripting language. So you start from the top, go to 10. Well, that means that the pointer literally goes back up to 10. This is fine in principle, but it is a bugger to debug and tends to result in rather complicated spaghetti code because everything's kind of connected to everything else in strange, weird, wild ways. There are no functions in BASIC, and a few of the other things that we take for granted don't exist. For loops don't exactly exist, depending on the version of BASIC. And this is a particularly early example I'm going to be going to, so it doesn't have an awful lot of modern programming conveniences. He also, rather controversially at the time, had the idea that we would put in a command called input. There was debates about this, would you believe? A lot of folks said, well, computers are a tool for the mathematicians, and as such, why would we break the process of execution to take something from the user? That's silly. But they persisted. They liked the idea of input, and consequently, everyone on the campus made computer games with it. Because of course they did. Loads of them, all text-based. And there we go. This is the machine that you operated it with. This is a timeshare basic machine. I don't know if it's the exact one that Oregon Trail was written on, but what you see here, or rather what you don't see here, is a monitor. There was no VDU. I believe they existed in some form back then, but this didn't have one. This is basically a typewriter connected to a printer. So when your code used the command print, it meant it. It actually printed. Awesome. Making a version of Mario on this would probably be tricky. But this is what we are operating on. And on the campus, loads of games were made rapidly. Apparently, there were games that were implementations of American football and various other exciting things that I dare say were amazing to play in an entirely text-based form. But Oregon Trail, again, was one of those. These are the three gentlemen who created the very first version of Oregon Trail in 1971. They were student teachers, and they were teaching a course or a lecture at least on the Oregon Trail for history purposes. And they had a bright idea. Why don't we make a computer game about it to help people learn better? So they did. They sat there and blasted the whole thing out, shared it onto the machine, and it became a smash hit on the campus. Folks were playing it who weren't even part of the course. It was an incredibly popular game. Now, unfortunately, the computers at the time being what they were, when the semester ended, the computer would reset and the game was lost to posterity. The 1971 version will probably never be found. But in 1975, they were approached by a Minnesotan educational company, which is what at least 3 of those letters stand for. And they liked the idea of their educational game and asked if they wouldn't mind making it again. So, from memory, they blasted together a version 2, the 1975 version of Oregon Trail, which was similar to the original, but with some improvements, apparently. And this is the version which, if you do a little bit of internet searching, you will find online. So there we go. That's what it looks like running on a more modern terminal, and is, again, entirely text-based. So effectively what you were doing is playing with a text-based menu, and every now and then it's asking you what you want to do. Typically, it will give you a list of commands that you may carry out, each of which has a number, and then you type the number and press enter. I'm so sorry. And then we carry on, or enter a value. There are a couple of places where text is used, but mostly it's numerical because in this sort of interface, just make life simple. So great, there we go. This is our super duper exciting game. And what I'm going to do is recreate this in entirely functional style C#, or as close as I can get to it. I'm trying to go all out, which isn't necessarily always the way I'd exactly develop in production for work, but this is my project. I'm doing it my way with my rules. Let's see how far I get. This is what the turn sequence looks like, because effectively the thing has a turn sequence. if we have some initial purchases to make, which are things like oxen and ammunition, because yeah, we've got to shoot some things, and miscellaneous supplies, which puzzled me for a long time. This is what they're called, and the more I read into the code, what I realized is this is medical supplies. It's actually stuff you use when someone gets ill or whatever. But for whatever reason, that's not what they called it in the source code. Fine. And then we have a set of choices that you may make. You may hunt for food. You may go to a fort in order to buy supplies, which honestly is a bit of a wasted feature of the game because there is no way to get more money. You cannot sell anything. So you basically have whatever money you have at the start of the game, and if you spent it all at the beginning, then going to the fort is a waste of your time. Or you may just simply press on. And then there are a set of rather complicated, random generated events of various sorts that the computer determines whether they happened or not. We may encounter riders on the trail ahead who may or may not be hostile. I think the original version didn't say riders, it said something significantly less politically correct. But I think for the 1975 version, we went with riders. Then there are just generally random events. Finally, there was a set of events that happened in the mountains, but that only triggered if you are within the mountains. Every turn updated the number of miles you had traveled, and you win the game by reaching the maximum number of miles. And depending on the choices you make during the game, that will determine how many miles we travel this turn. And I say turn, in-game it's a week, I think. And at the end of every turn, it will display the new date. And then finally, we do a check to see have we reached Oregon. If we haven't, let's go again. If we have, then you get the fantastic, all singing, all dancing, elaborate end sequence, which I shall show you later. It is very impressive. Right, some code. This is actual source code from Oregon Trail from 1975. Now, I've applied a little color just to make it readable-ish to you. The original was basically a giant text file, so there is no color or formatting or anything. It's just pure text. I thought I'd try and make it at least a vaguely easy to read. Excuse me. So, interesting things on here, especially if, like me, you're a total nerd and love old programming languages. Rem. What is rem? Like I said, it was a requirement of the basic language that everything had to be a verb, including comments. Comments are also a verb. Rem is short for remark. So that's the equivalent of the old / in C#. We've got a print there, and again, when it says print, that's what it does. That pops up on your paper. Dim defines an array. For whatever reason, arrays are always defined with that $sign there. It's actually pronounced string, so that is C string. It's an array of size 5. There isn't actually no concept of strings as we understand them in BASIC. They're all arrays. There is no real distinction between an array and a string in BASIC. So effectively what I have done is define a string in a weird roundabout way. Input, there it is. So whatever the player enters in, and I will try to say player, but a weird thing I found, having done about 20 years worth of industrial programming, when I made my first computer game like this, it was really hard not to say user. They're a player, they're having fun. So I will try my best. So we're taking whatever the player enters and popping it in C string, checking to see whether C string is no. If it is no, then go to line 400. We don't have braces like we do in C# in these days. Effectively, the brace works by if and then condition, and if the condition is met, go into the brace and do whatever it is. In BASIC, it's the opposite. It's if condition is met, don't do the next lot of lines, which means I effectively have to reverse the logic of nearly every if statement in the whole thing, and then stare at it for ages, making sure I've understood this right. Because with a sort of very free and loose style of BASIC, you could do some really interesting things that are just not feasible in C#. And then, so what this is effectively doing is saying, do you want the instructions? And if they literally type NO, we're not going to get them. If they type anything else whatsoever, you're getting all of the instructions. Marvelous. Lynn there, I think, is just doing some new lines. So how would I do that? How can I make that? Oh, yeah, and also Thankfully for me, they did put a key at the end that explained what the heck all those variables actually meant, because it is a common thing in BASIC to give everything single character names. Now, I'm guessing it's for the purposes of saving memory or something like that, but it also makes your code nigh on unreadable. I have no idea how the guys did that in the old days. So I want to try and wrap some functional layers around this thing. So functional works on the idea that we have no side effects in any of our code. Our functions are pure. Fine. Now, there is nothing more impure than a human being. Therefore, we need to wrap some levels around the bit that involves interaction with the human being, because we don't know what that person is going to do with their fat old fingers. And Windows itself is quite capable of throwing all sorts of novel exceptions. So this is the basic interaction system without any layers yet. So see how happy the person is there? They're happy because they're playing Oregon Trail. It's that good. So we're going to interact with Windows. Now, I'm sure Windows can throw exceptions. And also, let's all bear in mind that the user, the player, see, told you, the player might enter all sorts of invalid input, and we have to take account of that. They might just simply hit enter with nothing. We also have to take into account all of that. Now, if I have to do this every single time I do an interaction, it's going to get quite tedious to write this code. So there we go. First little step. Let's stick an interface on the console. Because I'm a good guy, I write unit tests. Great. I can do a fake console. There are three possible things that can actually come out of an interaction with the player. They might enter something. That's the state. They might enter nothing. They just hit enter. Or an error might happen. I don't know what sort of errors can come from reading something from the console, but I will take it as granted that it is possible. And all three of these states require some sort of processing, and it may not always be the same processing. So those are the three possible conditions. Go. There. And this is how I represent it. This is an example of something called a discriminated union. And I'm not going to go into much more detail than that about functional theory, because you don't need to know. But think of it as being a bit like Schrödinger's type. If you had a public abstract class of type cat, which then could be inherited into a live cat and dead cat, we are representing all the possible states of cat as classes. This is the same concept. I'm doing it here with an abstract class and inheritance because C# doesn't natively support the concept of this is a type and I don't actually know which type, but it's one of these. That's something that you get in F#, and there is talk of bringing it into C#, maybe in C# 13, but until that happens, for now, this is one of the only ways that you can do it. There are NuGet libraries that do it as well. One of is a good one, but I'm going NuGet free. I'm just doing everything myself from pure out-the-box C#, or as close as I can get to it. So this is a maybe of T, meaning it could be any actual type inside. And it inherits off this with nothing. Now that means that the user simply hit enter. This inherits as something, and the something actually has a value called value of type T. So this is basically something in a box. The idea is that someone passes you the box with a cat. I don't know whether this cat is alive or dead. If I care, I will have a look. If I don't care, then I'll just pass it along, and I don't need to know what was inside it. So that's why you would pass it around as type maybe. By using it as maybe, you are saying, I don't actually care what this really is, but here it is if you need it. If you need to use it, then that's where we start doing a select statement a switch express statement to find out what type we've really got and then respond appropriately. And then error meant that an error happened, and if that condition happens, I've also got the captured error inside. So what I have in this box is either nothing, an actual value, or an exception. And I can open it and have a look and do what I want, if I care. This is my read line. So I have to put some try-catches in. Once again, this is never going to be a pure functional language. We have to put some considerations in there for the fact that exceptions are still a thing in C# at all. Now, I try and keep these as pushed as far to the fringe of the system as possible. So if you start seeing things like try and catches in my code, it's only going to be on the edges of the system where we're communicating with something external to our code. In this case, the console. I might also do this, say, for a database operation, but only right at the point that we're actually triggering the database operation, only there. And so there are little bits of try-catch dotted around the edges, but then once we have passed the edge of the system into the functional core, then everything will be entirely purely functional. Now in this case, what I'm doing is, so try, do the console read line, do a string.is null or white space to say, is it nothing? If it was null or white space, then we return nothing. If it was actually a string, we'll return it. And finally, if an error happened, we return the error. But we'll reference it as maybe of string to say that there's a string in here, maybe, and then pass it around to whoever actually needs to open the box and have a look at what's in it. If you were doing this as a web application, then quite often I wouldn't necessarily open it until you've actually reached the controller action right at the end of the processor coming from the edges of the system back again, because it's typically only the controller that really cares what's actually in the box. There we go. And that's how I might handle it. So that's a switch expression to say something of string means that I will convert it into you entered this text, and a nothing means I entered nothing, and an error means I write it. That's an example of how I would consume a discriminated union, a maybe of. Now, strictly speaking, maybe should only have two states, something and nothing, but I find it a lot more useful to also say error, because real world, errors happen. So I don't know if there's any very pure functional guys around here, but I'm sorry, but it's the way I do it. It's fine. And also I have to represent things that have no return type. But I still want to capture whether it worked or not. And I've called it operation. There's probably other words for it. A very common thing, in fact, I've found with functional programming is that there's not entirely a consistent set of names for everything. There seems to be at least 4 or 5 names for some of the concepts. So I may have used one set of names. There may be others. There's no great big book of this is the exact name and how you all do it. Or if there is, it's probably a maths paper that I'm never going to read. So operation represents basically void. So I never return void in my code, I return operation. Operation means I did what you asked or it failed and here's why. If it's a success, then there's nothing inside it because there's nothing further to say, it worked. And if it's a failure, then it's failed and here is the reason, here's the exception for you to examine. Go. I even created an extension method. I like extension methods. They get a bad rep, but they have their uses, provided you don't put business logic in or anything useful like that. But so I have attached it to T being everything, and then asked whoever's in the outside to pass me an action to do with this, and then I'll put it inside a try-catch, which is one of the, again, the few try-catches in my whole system. Run the action, and if nothing resulted in exception, then we'll return success, otherwise return failure. There we go. And here is what a write line to the console might look like. Now, I've had to use a for each here. Reason being, as far as I'm aware, there's no way do a write line with an array of strings. And I wanted whoever's in the outside to be able to pass an array of strings so we can do a line at a time. And again, what are we going to do? So I could do message.try operation, and then that means that the try-catch is now implicit in try operation. There is no need to put a try-catch around this any longer because any exception happening inside whatever I've passed into try operation is already captured with a try-catch. And so I'm writing to the console. Whatever message you've given me, I'm going to go one at a time through your lines and write them to the console. There we go. But if you think about it, there's actually an additional set of states that I have to think about. So another level I want to add in. I mean, error and nothing are still what they are. That's fine. But there's 2 possible somethings. The user, or the player could have entered text or a number. In this specific case, that's significant because 95% or more of the inputs that I capture from the player do actually need to be integers. And I am far too lazy to do all of those try parses every single flaming time. So I've put in an extra level of state there. This is data from user on this line. So something I am branching out into text and integer because those might be important. I've now got 4 possible states in my Schrodinger's box of states. They could have entered text, they could have entered an integer, they might have just hit enter, or an error occurred. And bit by bit, what I have done is I am gradually refining the raw input from the player and stage by stage turning it into something that makes sense logically to the system. The data from user represents the processed, refined version of whatever it is that they've entered. And then that I can actually pass into the turn engine to be used and understood properly. There we go. That's my new set of discriminated unions. So I've called it user input. It's an abstract class. You can't instantiate it. And then that inherits into empty input, text input, which contains a string, integer input, which actually contains an integer. So if they hit an integer, then it's not only definitely an integer if it's an integer input, but here it is in integer form. And then an error. There's a big old bit of code for exactly how I do this, but once again, I've got things like that. It's basically another switch expression. We're going with something when int.try parse succeeds, and otherwise something just where it is not null or white space. Those all result in your integer input and your string input, and then finally we got error and empty. So one slight annoyance is that in a purer functional language, when you have a discriminated union, you can actually make the code fail if you haven't considered every state that's possible with the union. But that's not really a thing we have in C#. It might give you a compiler warning at best, but there we go. So I have to put a default case in just to stop it moaning at me. It's that, or you just have to remember to come and update it if you ever change your mind. Now, given this game was written in 1975, that's less likely, but still, I've been good. There. And this is my replication of that first block. So this user interaction is the class that I've injected, which represents all interactions with the user. And get input, give it a string. Do you need instruction? Yes, no. And then we'll switch that to say, if it was a text input, when the text was yes, then we'll convert that into a Boolean true. All other conditions result in Boolean false. I've changed it a little. Originally it was you have to write no to not get the instructions, but no, not doing that. But because that switch is hitting on text input, it's guaranteed at this point to be text, and I don't need to do any further validation. All of the validation has been done by the deeper parts of the system, and I know for a fact that this is what we've got. If they did anything else, like just hitting enter or typing something else, then that will just turn into a false, and there's no real need to consider it further. Easy, isn't it? When I say that functional programming is more concise, this is the sort of thing I'm talking about. And this is a version of it where I am writing out the instructions. So I've got a Boolean, which I created on the previous slide there. Now I've got an if here. Yeah, now ifs aren't functional. This is an if with no braces, so this is never going to get terribly complicated, and I can kind of live with this, but hey, this is my code, and I'm trying to go really nuts level functional. So I created a function called write message conditional, where you pass in a Boolean expression of some kind, and then the message, and if the Boolean expression results is a false, it won't write the message. So just means I can do away with one more if statement. There you go, that's the whole thing. So do a user interaction to get input, and the text to the user player. The text to the player is you need instructions, yes, no. Then we will convert that into a Boolean with a switch expression, and then use write message conditional to say whatever came out of display instruction is here. You decide whether to write the message or not based on whatever that is. And at my level here in display instruction, I don't actually care, but you need to know what this is. So you're passing the data onto the place it needs it, not how you don't have to consider it where it's generated. Managing inventory is the next bit. This is my inventory. Now I'm using a record type here. I like record types very much indeed. It makes the whole process of creating new state objects quite simple, because you can just say create a copy of this one with this one change. So makes functional style state management very simple. Now, the bits and pieces, we need an oxen team, food, ammunition, clothing, and miscellaneous supplies, which is not a euphemism once again, it's medical equipment. Don't know, but I don't know why they went with that nomenclature, but they did. So I am trying to respect the 1975 original because I'm inclined that way. Okay. This is a block of code that tells you how to start setting up your inventories. So initial purchases, the rem is thankfully actually there to help me understand what the heck's going on. We've got a set of variables, each of which represent the current spend on one of the items of inventory. They're all being set to 0 there. It's that extraordinary line of code there on 820. And then you're asking how much you want to spend, taking the input, validating it to say that it's, and again, this is one of those weird inverted if statements compared to what we're used to. What it's saying is, if it is valid, skip the error message, because that's the way it works. And this is what we'll do with everything to send us different error messages and different skips and so on and so forth, until eventually we've gone through this whole thing. And then at the end of it, there is another step that says if the player has overspent because they only have $700, and if they spent 704, then go all the way back to the beginning and do the whole process again. Wow. I mean, there was no GUI or anything. They were very limited, and under those conditions, it's still fairly impressive. Okay, that's what it looks like in diagram form. Let's first check oxen. If you've spent less than 200 or more than 300, you moan and then go again and say oxen again, please. Food and all the rest, they simply have to be greater than 0. The original 1971 version of Oregon Trail apparently had a bug where you could enter negative dollars and make phenomenal amounts of money by buying supplies. So the 1975 version has corrected that bug with a greater than 0 check. And then finally the total spend at the end, and we'll loop back around if you've spent more than $700. Great. But if everything matches, then we'll actually start playing our game. So here is a version of what I might do. Now I've got a while loop here because in the C# world we're going to have to do something like this. Now there is 2 kinds of loop in the programming world. There is the definite loop and the indefinite loop. The definite loop is something like a for or a for each, where I know precisely how many times I'm going to go around. Ish. I know that that's not exactly how that works with enumerables, but in principle, I know how many times I'm going to go around. That's easy in functional C#. That's just a select statement in LINQ, so no problem. Then there's the indefinite loop. I don't know how many times I'm going to go around. I'm going to carry on going around until I'm ready. Now in this case, it's that the player should have entered an integer which was within an accepted bound, and if they haven't, we'll go again. So can we do indefinite loops in functional C#? Well, there are a couple of methods. The short answer is not really. The long answer is kinda ish, a bit. There are a few techniques, so I'll show you shortly. Let's do, so in my code, this is one example, and this is using recursion. So I'm doing my get oxen spend, doing my check. If it's not valid, I'll call the function again. Now you can do that. Recursion is a very powerful tool, not unlike myself, but it isn't very kind to the memory of the system. So unless you are really sure that this is not going to loop all that many times, then you can do it. But if you don't know how many times you're going to loop, if there could be hundreds or thousands of iterations, doing that recursively will cause the system to just clog slowly until you get a Stack Overflow exception. I found that out the hard way. So I don't necessarily recommend recursion. Now, F#, different story. F# implements something called tail optimized recursion calls, which means that basically you can do recursion and it's fine. Because behind the scenes, little secret here, it turns it into a while loop. Which, let's be honest, is the only way to do it. Well, it's not actually a while loop, but yeah, well, I'll show you in a minute. So that's one way you could do that. But I'm not going to because I don't know how many attempts they're going to have to get my spend oxen. So I have created an extension method which attaches to everything. You can just about see it up there. It's called iterate until. That's what I have called it. What this means is I am going to give it 2 functions, two func delegates rather. So one is the process I want it to do. The other is a check to say have I met end condition yet? Now, end condition there is down the bottom, it's that it's an integer between 200 and 300. That's my end condition. And then the bit up there is the actual body of the loop contained inside a function. And it's going to return something which will then be checked. And if we're wrong, we'll do it again. So what does that look like behind the scenes? It's a while loop. Okay. It is the only way to do it. At least in the C# world, it's the way it is. Now, actually, the technical term for this is trampolining, which is a technical way of saying hidden while loop. Because how else am I going to do it? I mean, honestly. But it does mean that the performance level of this iterate until is pretty much the same as a while loop because it's a while loop. And so there's no performance hit, unlike recursion, which might well have and it means that there's only one. Okay, I've only got one while loop in the whole system. It's there. That's it. That's the one. Every time I ever now do a while loop, I'll literally use that one. Now, if one day we get an alternative in C#, then I'll switch this, the implementation of this function into whatever the new thing is, and there we go. Sorted. Fine. There is another way of doing it in case you're interested. Now, I recommend doing this with extreme caution. The goto statement still exists in C#. It actually does. That is what it looks like. But unlike the old wild days of BASIC, you can't simply go to an arbitrary part of the code base. You have to define a tag which is in scope where you use the goto, and then you can go to that tag. I am never going to use this anywhere else except this exact condition. There's probably maybe a performance benefit, I don't know, and technically I'm very, very, very slightly more functional than using a while loop, but it's up to you, do what you like. I would have no issue whatsoever with simply using a while loop, at least just one, and then referencing it. But this does the same basic concept. It's checking, and if your condition is met, then we'll do a goto. Anyway, get a non-zero spend, pretty much the same sort of process, but everything else after this point all requires a simple non-zero spend, so I'm not going to bother to make a separate function for each and every inventory item when it's the same process. So I'll just put a string in there that tells me which inventory item it is I'm getting, and then genericize the whole thing to be how much do you want to spend on thing, do an iterate until it's an integer, and then finally return out. Now, you notice the green underlining there? That's because the compiler can't tell that what I'm returning is definitely an integer input. It is. I guarantee it is, because it is impossible for it to be anything else, but ReSharper and Visual Studio can't quite tell. So just ignore that. Don't look at the man behind the curtain. Oops. There we go. And then what I can do is just do a set of calls to this, stick it all into a great big array, and then compile it later into a single object from this array of items. I'm using an enum to indicate which item it is that I'm doing the inventory for, and then it's quite simple just to create a single inventory record based on all of those items. Great, easy peasy. And there's my whole process of getting the initial inventory. Took me ages to explain, but reading that code doesn't take very long. So we've then got the total spend being greater than 700. That also has to be taken into account. That's another indefinite loop. We've got a problem here because, I mean, I could do iterate until, but to be honest, I'm fairly sure that the player's not going to do that very many times, because there's only so many times you're going to go through the whole wizard until you just decide to flip the desk and go and play something else. So I'm okay with making that recursive. Right, now the turn system. So there's a whole set of things that have to be done in each turn. And at the end of each of these, we have to do a check to see, have you won, or is the player now dead? Either of those will end the game. Now, there is a cliche about Oregon Trail that everyone dies of dysentery. In fact, that does not exist in the 1975 version. You can only die of two things, pneumonia or injuries. So those are our... Am I out of time? No? Sorry. Oh, no. Forget. Right. So I've created a function which attaches to the state object. And each time you call it, it has a function inside it. Now, each of those things we've passed in are functions, and they are modifying the state, by which I actually mean they're taking the old state and making a new one modeled on the old one. But at each point, I want to check to see whether the player is dead because I don't want them to carry on through the rest of the game. So contained within continue game is a check to say, check state, has the game ended, in which case, don't execute the function that's been passed in. So I have only one flow of instructions here, but if at any point, like for example in, I don't know, Riders on the Trail, they encounter the riders and it is a terminal encounter, then their status will be changed in state from alive to dead. Therefore, in the next function, handle random events, the continue game function checks, realizes they're dead, and does not execute handle random events. So one long flow, and the branching if structure is built into it. This is an incredibly simple and not technically quite right version of a monad. But again, I'm not going more into functional theory than that, and this technically it's an art, but it's close. That's what continue games looks like. It's a tiny, simple little thing, and it's literally just check to see whether the game's over. If it is, then just return the unmodified state back again. If it is not over, then execute the function and then return the result of the function. Quite simple, but very powerful. So, yeah, aren't I good at drawing? Let's have a look at a few of the other bits, and then we'll wrap up. Here is the incredibly impressive mini game for shooting. Isn't it good? So, how do you do a shooting minigame in text? You get the player to enter the text bang. We count how many seconds it took for them to type bang, and the number of seconds is used to determine the quality of their shot. Now, if like me, you're a pretty fast typist, I can get it nearly sub-second, so I'm basically a hotshot in this game. If, on the other hand, it took you 7 seconds, then you probably missed. And if they typed anything other than bang, you missed. And missing is considered to be the number 7. So that's the worst result you can get. There you go, that's how it's done. There is no return or anything in this because no concept of functions exactly in BASIC. There was a go sub, which means treat this line as a function, but it's only a line because go sub says it is. And there's my version. Take the start time. I'm using a current time service, which is basically my wrapper around a date time .now because that's impure, because it's different every time you call it. So I have to put it inside an interface. And then get the input, check it to see is it a text input, and then it's bang, and then we can say, okay, time taken is the return or else 7. Simple. And an awful lot of that is just the usual plumbing that we need to set up the class. The rest, the actual lines of code is 1, 2, 3, 4, 5-ish. Okay, riders on this trail ahead. Anyone remember this guy? No one does. I feel very old. No one remembers Brave Star? No. Oh, I got a nod. Oh, good, thank goodness. I thought, yeah, I'll put Brave Star references in this. Everyone loves Brave. No one remembers it. Literally just me. You probably recognize the naffing ponies, though. Not as cool as Brave Star. Right. This took me more time than you will ever know. Because this is bizarre levels complicated. There are many, I'm not going to go through the whole thing, but the process, as I finally understood it, is roughly check to see if there's riders, then do they look hostile, then were you right? And we have got a whole mess of if statements to handle that 3-stage logic. Finding a way to render it in C# took quite a while. And that's, oh, RND, by the way, there is a random number generator. They use some crazy complicated equations for that. Right, and there's my version. Are they riders? Do a random check. And then to say, if they are, then encounter riders, otherwise return unmodified state. There we go. Okay, let's just zip through this bit then. Fine. Yeah, it's the same basic idea. We're going to do a check to see whether it's integer, blah-de-blah-de-blah. Make your choice, and then I'll do this. Let's skip ahead a bit. Do some writes. Oh, finally, let's wrap up here. So this is the all singing, all dancing end sequence to the game. We check to see whether the origin has been reached based on the distance, and then you notice the funny little speech mark 7 thing in there. So that was a command to ding a bell. So there was actually a little bell attached to the terminal, and whenever that was there, because it actually printed these things one character at a time, and if it reached the speech mark 7, it went ding. So you ding, finally arrived, dinged at Oregon City. Someone did once suggest maybe it was playing a tune. I don't know. I've never seen this in real life. I doubt it somehow. I think they were just going ding, 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 because why not? It sounds cool. And if there was a bell, let's be honest, wouldn't you want to ding it? I would ding it. I would make it ding all the time. Finally, other games I might look at one day. This is one of the very first games ever made of Star Trek. And true to the spirit of Star Trek, what you have to do is fly around, finding Klingons and explaining why they shouldn't be there with laser weaponry. Very Star Trek, that. Bold and exploring and all the rest of it. Mostly involves exterminating Klingons. Great. But I might well do that one. But that requires a little bit more complicated stuff because you've got an updatable map of the universe. There is a Doctor Who one, but it is so complicated and so large that the game comes with the data of the game in compressed form, and the first thing it does is uncompress itself and then execute. So that's going to take me a lot of staring before I work out how on earth to do it. But there we go. I am a big fan of Doctor Who, so I may well do that one. Zork. I might well do that one someday too. Zork is the best. Do not watch out for being eaten by a grue. And finally, and then I shall let you guys go, I have a book coming out. It would be remiss of me not to mention it. It's coming out in 29 days or so. It's just about out now, finally. You saw me messing with my phone there. That was me actually emailing O'Reilly some stuff that they need because the final deadline of going to the printers is tomorrow, I think. So there we go. O'Reilly have sent me this URL, which you can feel free to use, and I think it gives you a month on the platform. Please feel free to read whatever book you like, but I would be grateful if you have a look at mine. That's also an out-of-date picture. I have actually got my animal, and apparently what O'Reilly did was say, this guy is British. What we shall give him is a coyote. I have no idea, but I'll take it. It's my coyote, and I shall love it on principle. And it's quite cute. You can look it up if you're interested to see my coyote. There are plenty of pictures of it out there. Right, any questions? We're out of time, so maybe come to me for questions, but otherwise, thank you very much.